Hello everyone. Today I want to tell you something about set theories next questions. Before that I have done for you that some questions which are not visible, that I'm sorry from my side. I'm making it today that everyone can understand these things. So I am starting furthermore. Let's do that. Then I will promise you that I will make it possible again to you. Prove that A contained in B if and only if its complement B complement contained in A's complement. First of all, I want to tell you what the mean of complement and what is a set. A set cannot belong to its complement. Suppose a set A is equal to 1, 2, 3, 4 and B A's complement must be equal to 5, 6, 7, 8. Because if we are taking any complement, that means that does not belong to that set. So we have first question, prove that A contained in B if and only if B's complement contained in A's complement for all sets A and B. Assume that A contained in B. It means to say we are to prove that B's complement contained in A's complement. First of all, we have given that A is contained in B. So let X is any element that belongs to B's complement. That means to say X belongs to B complement. That means to say X does not belong to B ever. So this means to say X does not belong to A also, because in the start we have said that A contained in a B. That's why. So X does not belong to A. That means to say X must be belongs to A's complement. So that means to say B's complement, because we have taken an element that belongs to B complement. That's why it is go in a A's complement. So that means to say B's complement contained in A's complement. So this implies B's complement contained in A's complement. That's what we have to prove. Now the question is second one. Assume that B's complement contained in A's complement. We have to prove that A contained in B. For that, let Y is any element of A. That means that Y belongs to A. This means Y can never belongs to A's complement. And this implies Y can never belongs to B's complement. So this implies Y must belongs to B. Y must belongs to B. So this implies A must contain in B. So this implies B's complement contain in A's complement. This implies A contained in B. From 1 and 2 we have proved the question. Now that B's complement contained in A's complement. Now we have reached to second one. If A and B are and C are any sets, then we have to prove that A union B is equal to A union C and A intersection B is equal to A intersection B if this implies B is equal to C. So let X be any element of B. That means to say X must belongs to A, this, or X doesn't belongs to A. So this implies X belongs to A, then X must belongs to A intersection B. This implies X belongs to A intersection C, because all these are combined elements. So this implies X belongs to C. So but X is any element of B. So this implies B contained in a C. So case second, X doesn't belong to, first of we have taken X belongs to A. Next we are taking X doesn't belongs to A. So this implies X belongs to A union B. So this implies X belongs to A union C. So this implies X belongs to C. Now we have B contained in C. So next we have from both the results we can get that B contained in C, C contained in B. This implies B is equal to C from 1 and 2. That's what we have to prove. A union B is equal to A union C and A intersection B is equal to A intersection C. This implies B is equal to C. Haji, next I want to tell you something about relation. What is a relation? Beta, relation is that thing that is in Punjabi or Hindi we called it जो रिश्ता होता है उसे relation कहते हैं. But in mathematics we have different things. What is the relation? We are relating, it is denoted as capital R. And how we can do that, I am going to tell you. First of all, we have order pair. What is order pair? Let A and B be any two sets. Then an order pair can be represented as X comma Y, where X belongs to A and Y belongs to B. So this is a ordered pair, beta. What is the mean of order pair? Anything which is in a bracket was said to be ordered pair. Next is concentration product, या Cartesian product of sets. What is the Cartesian product? If we are writing any two sets is Cartesian with a has the Cartesian product, then I am going to tell you. If suppose A cross B, that is represented as x comma y, this implies x belongs to A and y belongs to B. Similarly, suppose A is equal to 1 comma 2 and B is equal to 2 3 comma 4 comma 5. So A cross B is equal to, first of all, 1 3, then 1 4, then 1 5, and next is 2 3 comma 2 4 comma 2 5. This is called A cross B, beta. This is very important. You have to mirror what is a Cartesian product. Next we have how we can explain a relation. What is a relation? How we can explain how we represent a relation. A relation R from a non-empty set A to a non-empty set B is a subset of the Cartesian product. Again, I am told you that Cartesian product is most important. Again, we have written Cartesian product A cross B. So, what is a relation? Anything which is represented a Cartesian product is said to be a relation. The subset is derived by a describing a relation A between the first element and the second element. Mean to say A cross B is said to be have the relation. Let R be a relation from A into B. That means to say A comma B is represented to R. This implies A belongs to capital A and small b belongs to capital B. If AB does not belong to R, that means to say R is not a relation. So this means to say AB does not belong to R. Okay, beta, thank you. Do that very well. We will meet you on tomorrow. Thank you.